Okay, so how's everybody doing? Good? You all psyched about the midterm? What's tiring you out now? It's not one of my assignments.
Cognitive science midterms.
Cognitive science midterms. I see. Okay, good luck with those. So today actually is just it's sort of a review class for the midterm. So a little bit of information about the midterm. It's going to be 20 plus 1 multiple choice, Scantron questions. 21, one question is a bonus.
Bonus multiple choice question.
A bonus multiple choice question. It's the hardest one. Don't worry if you.
How many options is there for it?
It's just more to get you thinking. Then there's only 5 options.
So you have a 1 in 5 chance of getting it right.
Yeah.
Do all the questions have 5 options?
Some of them are true and false, so some of them only have 2, some of them only have 4. But it's not much to worry about. It's 1 hour and 20 minutes, which means it's from 10:05 till 11:25. That's as long as we have the room. So what I would like is for you to be here in class and sitting down, all your crap put away before 10:05. So as soon as you can get in this room, come here. The tutorial beforehand, well, that's for studying. So you can either go to the tutorial room and study with your classmates and getting help from the TAs who are supervising the tutorial, or you can, if you prefer to just not do that, I won't say stay home, because if you stay home then you won't make it here in time for the exam. Go study in the library or wherever else there's a quiet spot. If you prefer just to study alone, that's fine. There's a tutorial mark in this course. Skipping this tutorial will not affect your mark in any way. All right, so the questions, well, it's a multiple choice exam, so it's not really about being able to write code. It's mostly about reading and understanding code. So most of the questions are of the form, here is a piece of code, and then there's some options that describe things about that code, like this code prints this, this code prints that, this code prints some other thing, this code prints some other thing. So really, it's just about being able to read code and understand what it's doing, which means understanding it and then understanding a little bit about basically all the concepts in this course. And the code samples are very closely related to assignment questions. Okay, and the reason I do this is that, well, there's a couple of reasons. So one, assignments are not worth a ton in this course. So assignments count as 30% of this course, although they're the bulk of the work that you're going to do for the course. That's not my choice. That's sort of the way the university likes it. This midterm exam, which is going to take 1 hour and 20 minutes, on the other hand, is worth 20% of your final mark. So it's worth as much as 2/3 of your assignments. And so what I would like is that your midterm exam mark really is a reflection of how well you understood what was on the assignments. So that's what I want. Yep.
Are there going to be any truth tables on this exam?
No. Nothing explicit. There may be, to read code and understand it, you have to be able to work out, truth tables in some intuitive way or some some good enough way. I mean, anytime you have to understand whether an if statement executes or not, you're basically evaluating the truth of some statement. So, so nothing formal, no formal logic. Really, just understanding code. The two exceptions of what's closely related to assignments is the recent stuff, because you haven't had assignments on it, and that's inheritance. Well, basically object-oriented stuff, so inheritance, polymorphism, those things we discussed last class. So last review lecture is a good, the last lecture is a good source of review material for that. And the other one, which actually cropped up on an assignment, but we don't really, I mean, I don't go out of my way to test this understanding of this on assignment, is the difference between equality, testing if two things are equal, or identity. And that's testing if one thing is another. Okay. So those two topics, you sort of, there's a little bit about those, and you need to understand them as well, even though you haven't. I mean, you've done an assignment where you created a couple of classes, but there was no class hierarchy there, and therefore there was no polymorphism happening. So understand that stuff. And the bonus question, I'll even. It involves probability, something which you know nothing about, because probably none of you have ever taken a course in probability, but it's the kind of probability that you, I mean, when you're just chatting with friends about statistics, you talk about these things. Okay. So it doesn't matter anyway. The bonus question is not a big deal. Yep.
The bonus question just ends on our assignment, so if we get it wrong, then we can if we get it right.
Yes.
So if we get it right, we can possibly get like 100.
No. So you can only ever get 100%.
What if we get that right and we get everything else right?
Then you'll get 100%.
Then,
Yeah, why can we never get above 100% in this class?
like, come on.
Yeah. Well,
Some classes you can, I think.
because it's not going to help you out in the end. Okay. So the plan today for review then is just to go back over the assignments and highlight a few of the questions we did and do them together, just so people understand them, and maybe they'll actually see other ways of doing things. Because one of the difficulties with multiple choice, and even though I take things right from the assignments, so you could have done the assignment, got it perfect, and then I show you, use as one of my samples, a solution to an assignment question which is nevertheless very different from your solution, and it's so much so that you can't even understand what it's doing, and you can't answer questions about it, even though it's identical. I mean, its functionality is identical to something you did. So so it's worth looking at these, even if you think you know how to do all these questions, just to see what are the other possible ways of doing them. So let's start at the beginning. And let's look at a couple of questions from assignment 1. And let's really start at the beginning, and we'll look at 1.1. Easy question. Probably the easiest assignment question in the course. Of course, in the sample output that I did it incorrectly, just to show you that nothing is really that easy. course, that was intentional. Here we are from last class. Okay. So we want to convert from pounds to kilograms.
Are you recording?
Yes. So we have a weight, W, expressed in pounds. We want to convert that to kilograms. And read the function carefully. It says the function should return the weight W expressed in pounds as a mass expressed in kilograms. So in particular, it says it should return this thing, not that it should print it or anything like that. It should just return something, so that says we want a return statement. And how do we convert a weight in pounds to a weight in kilograms? W divided by 2.2. Yep.
Are we going to get like what kind of error message will this give us? Kind of thing on there?
There will be questions. I know that there are questions of the form, this function does this function does that, this function does another thing, or this function generates a name error.
Okay.
This function generates
like, what type of error just going to be like it generates?
it might specify
Okay.
that it's a name error or an index error or whatever. So it would be good to know. Is that correct? Yeah.
Yeah.
Yeah, it's pretty hard to get it wrong. If you can also do it the other way and multiply by 1 over 2.2, whatever that is, so 0.454 or something. I don't know what it, yeah, something like that. Let's just check it. So 1 pound is 0.454545 something kilograms. We could be a little bit more accurate, but this is otherwise correct. Okay. A little more sophisticated. Well, let's do 1.7. I want to convert inches to feet and inches. So I have a length I expressed in inches, and I want to convert that to a length that's expressed both in feet and in inches. Yep.
You need to refer your thing by I divided by 12.
So I divided by 12.
Yeah. Or sorry, integers, and so divided by 5 times.
Yep.
And then you need to return I mod 12.
I mod 12. Okay. So I want to return a tuple. Well, the first part is the number of inches divided by 12 without any fraction, so the whole part of that division. That tells me the number of feet. And then the number of inches mod 12 gives me the number of inches left over after taking away all the feet, taking away all the multiples of 12. So 24 inches is 2 feet and 0 inches. 28 inches is 2 feet 4 inches. Seems to work. Okay, so what is this function returning? Yep, a tuple. So it's this thing like an array, but you can't change its elements. They're fixed forever, and it doesn't grow, it doesn't shrink. So it's just this tuple of length 2. We usually call that a pair. All right. How about this question, which asks you to convert from feet to feet inches? So I have a length expressed in feet. I want to convert it to feet and inches. Yeah.
You turn feet just into feet.
So different ways we could do that.
And
So
then,
we want the whole part. We can just convert it to an int. Yeah.
and then you gotta go feet times 12. And then 12.
Feet times 12.
Yeah. Not
12, like that.
Yeah.
Okay. So 3 feet. 3 feet. What's 3 1/4 feet?
4.
3 feet 3 inches. Yeah.
And you get
3 1/2.
6.
3'6". Okay. Seems to work. So notice there's something slightly different here that that we get that the inches start getting expressed as a floating point number, even though they could be expressed as an int. That's not that easy to solve.
But then if we have it so that way it's no longer, because sometimes we could have a decimal in it because we're using just feet, like root point something.
Yes. Yeah. So if we did something, I mean, well, when we do something like just 3 feet, we get that. Okay. So all easy stuff. And again, this is returning a tuple. A tuple of length 2. It's a pair of elements. Let's do something a little harder. And something that has more than one way to do it. Factorial function. So I want to compute the product n times n minus 1 times n minus 2 times n minus 3 and so on down to 1. There are many ways to do this. So somebody give me a way. Yeah.
Or with a multiplication function that you can define using lambda, you can just reduce the range from n, or from 1 to n plus 1.
Okay. So xy. And what's the range I want to reduce?
1 to n plus 1.
Yep. Factorial 2 is 2 times 1, which is 2. Factorial 3 is 3 times 2 times 1 is 6. 4. That works. Does everybody understand how what happens there? So we defined a little function, has no name, but it takes 2 arguments and multiplies them together. We created the range, which contains the elements, well, we can see this, range 1 through 5, for example, contains 1, 2, 3, 4. And we reduced that set that looks like this, except it goes up to n. And we reduced it using this multiplication function. So this starts by multiplying 1 times 2, and then the result of that gets multiplied by 3, the result of that gets multiplied by 4, and so on. How many of you implemented it this way for your assignment? Just very few of you. How else did the people implement it? Yeah.
Use the while statement.
Use the while statement. Let's see what that looks like.
So x equals n, and then c is n minus 1.
Okay.
It ends up working.
Okay, I might start a different way, but let's say, let's call it P for product, and we'll start at 1. Yeah? So do you want to use a while statement, or do you want to use, so what is your while statement going to do?
The while statement basically it's while c. The way I did it was like, because c is n minus 1, so then it's like while c is greater than 0, you x equals x times c, and then you do c minus 1, and then just returns x over and over again.
Okay, so we can do that. Here's something that should do that. While c is bigger than 0, p equals p times c, c equals c minus 1,
And then again, just return back.
which in our case is p. Let's try that. Factorial 2, factorial 3, factorial 4. Seems to be correct. So here we're using p as what's called, usually called an accumulator. So it's keeping track of the calculation so far. And c is a counter, which starts at n and counts down until it hits 0, in which case we don't continue anymore. And each time we go through this, we multiply first by n, then by n minus 1, n minus 2, and so on, all the way down to 1. Okay. A variant on that, whenever you have a while loop which is controlled by a counter like this, we always have a better way of doing that. A for loop is really what those are made for, and they're in just about every programming language. And they're particularly easy to use in Python. So we're counting from 1 to n plus 1. It doesn't matter if we count forward or backwards, actually, since it doesn't matter if we multiply, if we change the order that we multiply things. And that works as well. Any other solutions? Yeah.
I can use recursion for this.
Yeah. So what's recursion? Yep.
When a function calls itself.
It's when a function calls itself. And what's something that, so many of you have not been exposed to this, what's something that every recursive function needs? Yeah. Yeah, so it'll have to call itself or call some other function that calls it back. But more important than that, yeah.
Control break statement.
Yeah, so it needs what's called a break statement, because if a function that calls itself always calls itself, then that will never finish, right? If you just keep calling the function that calls itself continues to call itself forever, then that function never finishes. So it needs what's called a base case, which is when the function is finished. And in this case, the function is finished if, let's say, if n is less than 1, or less than or equal to 1, however you want to do it. So what's factorial of n if n is less than or equal to 1? What's factorial of n if n is equal to 1? 1. So that's what we'll stick with. Factorial of 0 and factorial of -1 and factorial of -2. It's not clear what those things should be anyway. So we'll stick with just returning 1 if n is less than or equal to 1. Otherwise, how can we define factorial? It's n times factorial of n,
n minus 1.
n times factorial of n minus 1. Okay. So yet another way of defining factorial. Using recursion. Okay. So we don't do recursion much in this course, but it's good to know that it exists because you will see code like this. I'm not a big fan. So in some languages, recursion is the way to do things. Python is not really one of those languages. And if you get really hooked on recursion, you will write things like this. You will write things like the way to add up an array is to take the first element of that array and then recursively add up the rest of the array, which works and is correct, except that if the arrays get big, it gets both slow and eventually actually stops working entirely. So we don't, Python is not really a language for using recursion in. Well, I mean, it is, and recursion works fine, just as it does in other languages, but it's not the immediate thing you should think of as a solution for these kinds of problems, is to do them recursively. Okay. How about... Oh, there was one more I wanted to do, actually, from assignment 1, which was this thing for formatting a name. So write a function that formats a name. So it should print the last name, the first name, and appellation with comma in between. Okay. What's one way to do that? Yep.
Return, and then you have percent s 3 times with commas in between.
So my preferred way is this. So we want the last name, first name, and the appellation. Okay, so that works. Anybody, is this how people did it on their assignment? No? How else did you do it?
Concatenate a string and just return the string.
That's basically what this does. I mean, how did you make the string, I guess, is the question.
Well, you just added fn, ln, and app.
Okay.
And then just returned it as one string object.
Okay. So another way to do this, which I'm not as keen on, but it's up to you and nothing stops you from doing it. You can do fn plus ln plus app. Is that what you do?
No, you need to.
Well, you add spaces between them.
Yeah.
And you add spaces between them with commas. So I don't like that solution. It's the kind of thing you end up having to do in a language like Java. Oh, and I got it wrong, of course. But it works too. So here you're just concatenating 5 strings together, the 3 strings that the user gave you, and then the 2 strings with a comma and a space in between. I don't know. I find you're more likely to get it right the first time if you use printf formatting than you are otherwise. And I know some of you did it like this. Is that correct?
No.
It looks kind of correct, right? The output sort of looks like what it should be, but it's way wrong. What's really ultimately wrong with this function? Yeah.
It's not all one string.
Yeah. So the function is not returning a string. It's actually returning a tuple whose 3 parts happen to be strings. So it's completely wrong. So don't do that. So from 2, we have 2.5. Threshold takes an array and a number or something, x, and returns an array that contains only the values that are greater than or equal to x. How'd you do that? Yep.
Use a filter.
Okay. So there's these 3 methods: map, reduce, and filter. Filter is the one that does this kind of operation that only keeps things of the array which should be there. So we want to filter, and the method we want to use is to check if, did I say greater than or equal to x? So greater than or equal to x, and do that on A. So let's say so 1, 2, 3, 4. 1, 2, 3, 4 is in our array. Let's try it. Threshold AA. Oops. And let's get rid of, only keep the things which are bigger than 3. Bigger than or equal to 3. So that works. And again, this is one of these functions that takes a function as an argument. The function we give it is this thing that has no name, that just checks if its argument is bigger than or equal to x. So it'll return true if it's bigger than or equal to x. And that tells filter that you should keep that value. And if it returns false, filter won't keep that value. Another way to do this? Yep.
You just return y for y in A if y is greater than or equal to x.
So this form, which they're called list comprehensions in Python, is another way of doing it. It's a nice way of doing it because it allows you to do 2 things at once, basically. It allows you to do a change if you want. So here we don't change anything, so we're just going to return the original value y, but we could have returned something else. And it allows you to do a filter by putting something after this if clause here. So give me all the values y that are in A, and but only if they're bigger than or equal to x. And that works too. Anybody else do it a different way? Yep.
I just made a new array.
Yeah. So a lot of you with programming experience did something like B is the empty array, and then for y in A, if y is bigger than or equal to x, B dot append y.
Return B.
Ah, damn. Return B. It looks horrible once you've seen other ways to do it, doesn't it? So that works well also. So this basically does the obvious thing. It creates an accumulator, B, which is an array in this case, and we go through each element in A, and as if that element is bigger than or equal to x, we add it to the end of B, our accumulator. Yep.
And even so, like, it looks less good than the other ones. I think that one's more efficient than the other ones. Because you only have to create a function and make it actual basically the same thing.
The first one takes up more memory because you're recreating A, so it ends up actually taking up more.
I mean, they're pretty close to the same level of efficiency. You can do timing tests, and you'll find that the list comprehensions are very highly optimized in Python, so they do it a little bit better. But one point that you brought up is, okay, this, let's say you say, is inefficient because you have to create this function. But if you think about it, well, when does efficiency matter for these things?
Well, when you do big arrays or...
It matters when you have a big array. So in that case, most of your time is spent actually just checking this condition and adding stuff. The fact that you create this function is small compared to the fact that you're going to go over an array of like a million or more. Yeah. So when thinking about efficiency, try and keep those kinds of things in mind. Statement that you only execute once is not really an issue for efficiency. It's the ones that execute a million times that are a problem. Yeah.
Wouldn't be one good thing about that one is the one where you're using the for and the if is it's easy for other people to understand who may not know code, because it's just like you can read it as if like it's an actual sentence.
Yeah. So this is easy for other people to understand who don't know how to code, or other people who know how to code in C, C++, or Java, or any of these other languages. This is actually something that a mathematician would read, and it's extremely natural for them. And the filter, that's not really natural for anybody. And with these lambda functions, not supernatural. But we all understand them now. So okay, so that's 3 ways at least to write threshold. One of these questions, the bonus question here, was a fairly fancy one, fairly difficult one, that asks you to write a really fancy time formatter, so that you give it times like 9:01 and it returns 9 o'clock, or 9:13 it returns a quarter after 9. We won't do the whole question, but one aspect of this question is being able to convert numbers, integers, into strings this way. Okay, so let's see how we can do that. Okay, so as to help you do this question, you might start by saying, well, I really need to be able to convert hours into just the string that represents that hour. For example, I would like it if the hour 0 represented the string midnight, and the hour 1 was the string 1, and the hour 2 was the string 2, and so on. The hour 15 would be the string 3 for 3 o'clock. So something like that. So, well, how would you go about writing such a function? So there's 24 possible hours. How would you write that? Yep.
One way you could do it would be to do a huge massive if statements that you set off the page, or you could just make an array that has 24 different string representations, and
Okay.
based on what number it is, tell it to refer to the array.
Okay, so you could make a giant if statement, and I think you all know how to do that. It would look like this: if h equals 1, return 1, and if h equals 2, return 2, and so on. Now, what you could observe instead is, well, really, these things, the hours we're looking at are 0, 1, 2, 3, and so on, up to 23, and all of those. So those are like indices. You could use them as indices into an array. So instead, you could